Recording in progress.
Rotations of the study places. To understand the use of Markov chains, our group has investigated about the most common places to study in the University of Navarra of a 4-year career. Our group has gathered actual data by sending a survey to classmates of the University of Navarra. We have gathered 132 responses to the 2 base questions of the project. In the question number 1, people have chosen where they study in the first semester. And in the question number 2, people have chosen where they study in the second semester. We also can see how many people study in each in percentage terms. A transition matrix in the Markov chain is a square metric that represents the probability of moving from one state to another in a stochastic process. The columns in the matrix represent the current state, and the rows represent the future state. The sum of each column in the transition matrix must be equal to 1, indicating that the system must transition to some state. Here we have the transition matrix with the results of all questions of the study places that the people used to go in each semester, showing the probability of moving from one place to another. The vector matrix M0 is a row vector that represents the initial state probabilities of the system. It contains the probabilities of the system being in each state at the start of the chain. This percentage we take from the result of the first question.
So changing into time is based off the 2 questions that we gather information about the students that they study in different places in now. So to calculate the probabilities of the system being in each state, after a one-time step, we can multiply the vector matrix by the transition matrix. You can repeat this process for subsequent times steps to calculate the probabilities at each time step. But in this case, our objective was to calculate M7 in order to know where the students will study in the last year of career, the last semester. So the equilibrium matrix in Markov chain is a probability matrix that describes the long-term steady-state probabilities of being in each state. Once the system reaches the state, the probabilities of being in each state remain constant over time. The balance equations, the equilibrium matrix is typically found by solving a set of linear equations that describe the balance conditions. The balance equations express the condition that the total probability of being in each state must remain constant over time, and they can be solved using matrix algebra to find the equilibrium matrix. The equilibrium matrix is a probability vector that satisfies the balance equations and represents the long-term steady-state probabilities of being in each state.
The eigenvalues of that matrix correspond to the values lambda that satisfy the equation P minus lambda times identity times x equals 0, where P is the transition matrix of the Markov chain, I is the identity matrix, and x is a non-vector representing the steady-state probabilities of the different states. By finding the eigenvalues and eigenvectors of the transition matrix, we can determine the long-term behavior of the Markov chain and the probability of ending up in each state after many iterations. The eigenvectors. The eigenvectors correspond to the scaling factors that determine the probability distribution of the different states at equilibrium. To find the eigenvectors of a Markov chain, first we need to find the eigenvalues of the transition matrix. We can reduce the augmented matrix P times P minus lambda times I to row echelon form, and then solve for the variables in terms of the free variables. This will give us a general solution to the system of equations, which will be a linear combination of the eigenvectors corresponding to the eigenvalue lambda. Conclusion. After a deep analysis, we can conclude that Biblioteca Central is the best place to study overall. Students may tend to change study places to Biblioteca Central more than any other place. It may be because the overall study session quality here is way better than in the other 2 places, except studying at home. In addition, studying at home is the first option for students since it is clearly more comfortable just staying at home. And this is maintaining for future changes in study places, meaning that students find the commodity of your home the second best place to study. Thank you.